Well, guys, let's try take number 2 because it's been one of those Mondays. Did its great thing, and then I realized I forgot to take the integral of it, which is not a good thing. So we're doing the area between two curves. So we're knee deep into integrals now. You guys have looked at Riemann sums where it's taking the area of each of the squares or the rectangles that we're creating. But that's just kind of the proof of why this thing works. So when we're dealing with exact values of the curve, our exact value have trouble spelling today too, is really the integral from a to b of f of x. So if we want to find the area or the exact value of the area under the curve, we're just going to take the integral from a to b of f of x. Now, when we're dealing with, let's say, two different lines, and we take this concept and we say, oh, well, if this one's 12, area of 12, and this one is an area of 10, what's the area in between? Well, if this one has an area all the way up here to 12, and this one only has an area of 10 in between it, what's the difference in area? Well, the area is going to be equal to 2. How did we get that? We took the upper and we subtracted the lower from it. Well, we're going to take that same concept where to find the difference between the two, we take the upper minus the lower, and we're going to say, okay, well, I can find the exact value of this curve by taking the integral of secant squared, and I can find the exact value of sine of x, the curve under the sine of x, and I can find the exact value there. And if I subtract the integral of this one minus the integral of the bottom one, I'm going to get the area that's in between the two. So if we take that concept and we say, oh, okay, well, I've got the area. This pen's a goner. Let's see if I still got my old skills. No good. All right. Okay, so if I have the area of the upper, and I have the area of the minus the area of the lower, let's start pushing that into our calculus ideas. Well, I can find the area by taking the integral from a to b of f of x, the upper f of x, which is secant squared of x. Okay, now I'm going to subtract that from the area of a to b from the lower, which is sine of x. Okay, now I've got this piece. Now these two match because we're going to go from a to b. So really what I'm saying is I need to take the integral from 0 to pi over 4 of secant squared x minus sine x dx. So basically I'm taking the integral from those two for between the lower and the upper, the left and the right x values, and I'm subtracting the two functions, upper minus lower. So if I integrate this, I believe I get tangent x minus cosine x. Okay? And I'm going to evaluate that from pi over 4 to 0. So let's take that thing, and I'm going to, oops, that's an x right here, guys. So I'm going to go with the tangent of pi over 4 minus the cosine of pi over 4 minus the tangent of 0 minus the cosine of 0. So then I get this is going to be the tangent of pi over 4 is 1 minus the cosine of pi over 4, which is root 2 over 2, and I'm going to get the tangent of 0, which is sine over, that's 0, and this is going to be minus 1 because the cosine, those are going to cancel, and I'm going to end up with negative root 2 over 2, but we cannot have a negative there, so my value is going to be root 2 over 2. Okay, can't have negative area units. So that's my idea behind that. I think this is actually supposed to be a plus, no? Yeah, I did mess up, sorry. So this is going to be a plus right there. I knew something was wrong there, so that should be a plus, because this is the integral. Integral of sine is negative cosine, so that's going to change that into that. There we go. So we're taking the area of the upper minus the area of the lower. So let's just do another quick one here. So let's say they give us, let's do what they're dealing with here. Y equals 2 minus x squared, and y equals negative x. So I've got this system here, and I know it's up at 2, 1, 2, and then I'm gonna have my y equals x is gonna do something like this, right? And I know that my curve is gonna go down something like that. And they want the area between the two curves, so we're really only worried about these two, this little graph right here. Okay, now, so we've got our upper. This is our upper, no problem. This is our lower. So we're going to take the exact value and we're going to deal with the same thing. So we're going to have the integral from a to b of the upper, which is 2 minus x squared, subtract the lower, which is negative x. Okay, so I've got this set up, but this is a problem. Where does it go? Well, we know I want it from this value to this value. So in your head, how would you find these two values? These two x values, how would I find those? Where do they intersect? Well, this is where this f of x equals the other f of x. So this is where y equals y. Y equals y. So we're going to set those equal to each other. So we're going to set those equal to each other, and we get 2 minus x squared equals negative x. So let's do some math here. Let's move it all over. We get here, get x squared minus x minus 2. So let's factor this out. What does it equal? Negative 2 and 1. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So my two x's is 2 and x equals negative 1. So here is x equals negative 1. And my second one is x equals 2. So my lower boundary is negative 1, and my upper boundary is from 2 to 2. So what are we saying? We're saying we're going to integrate this thing with the upper minus the lower, but we're going to integrate it from negative 1 to 2 because we're going to take all those rectangles that make up this thing. We got tons of them. We're going to make up tons of rectangles, and we're going to integrate it to find the area between the two. So let's clean this up a little bit. We're going to end up with, from negative 1 to 2, I'm just going to write this in order. Negative x squared plus x plus 2 dx. Let's integrate it. So what are we going to do? We're going to get negative x to the third over 3. I haven't integrated since the last time you guys integrated. Plus x squared over 2 plus 2x, and that's going to get evaluated from -1 to 2. So let's start plugging in numbers here. So if we get it, we get -8. I'm plugging in the 2 right now. Thirds plus 4 halves plus 4 plus 4. We're going to subtract that. We're going to subtract that from -1/3 plus 1/2 plus -2. So I'm just plugging in 1, -1 squared. So this is going to turn into a positive right here. So let's just, I leave the fractions here so we can clean things up real quick. So I got -8/3 minus 1/3. That gives me -9/3. I've got 4 halves minus a 1/2. Gives me a positive 3 halves. And I've got a 4 plus 6. So let's just keep cleaning this up. This is going to be -3, right? -3 plus 10 is going to be 7 plus 3 over 2. This is 1.5. So the area, approximate area, is 8.5. Okay? 8.5. All right. Why did that not come out right? What did I do wrong? What feels wrong here, guys? I don't know. Something feels wrong. It's 1, -1/3. It's -9/3, which is 3. That's -3. 1, that's 7. Oh, no, that's right. Upper minus lower. I'm going to have to think about that one for a second. Hold on here. We can fast forward through that. Somewhere my math has failed me, my friends. Oh, that's it right here. Jeez. Plus 2, which is 6. This is 6, so you might want to, that's going to be 6 total. There it is. I accidentally added plus 6 when in my head, so this is a total of 6. 4 plus 2 is 6. So then from there, this becomes 3, and that becomes 4.5. My math will get you every time. All right, so a little mess up there. Sorry, guys. So this 6 comes from 4 minus a -2. I did some math in my head, and I got myself in trouble. So that's 4.5 units squared, or square units. Okay, so one more quick idea when it comes to exact values for you guys. I'm just going to do the setup. We won't go through the calculations because this video is going to be long enough. All right, so let's look at the example they give us. They give us the square root of x and as one of them, and y equals x minus 2. So if you put them in your calculator, you'll get a better good idea, or put them in Desmos, I don't care. So if we're going to look at this, and we're going to do, oh, look at that, that's going to go like this, okay? And I don't know if it's just going to keep going, I guess. And then we have this value here, which is x minus 2. So I'm going to go down to -2. I'm going to go up 1 and over 1. And I'm going to take this thing and I'm going to draw a line like that, let's say. Okay? So now what they want is they want the area above the x-axis. So they want the area between square root of x and x minus 2 above the x-axis. Whoops. Okay, so this poses a small problem because here the upper minus lower is different. So we have to break this into two chunks, let's say. Part 1 is going to be the integral from 0 to whatever x value that is of the top curve, which is going to be the square root of x. So we're going to call this x1. And then the area here, which is part 2, is going to be the area from x1 to x2 of the upper minus the lower. Upper minus the lower. And this value here is x2. Now we can set those equal to each other and find it with a value. You may have to use your calculator a little bit. And then we can also find the x-intercept for this one here by plugging it in and finding the x-intercept. So we can find our x1 and x2. The reason I'm bringing this one up is when you're posed with a problem like this, you have to split it into two parts, and the answer is going to be part 1 plus part 2. It's just one of those things you got to watch out for. All right, guys, I'm going to leave that one there. We'll be tackling this on Thursday also, so good luck, and let me know if you have any questions.